Electromagnetic wave 電磁波 Light is an example of electromagnetic wave. Consider a light wave traveling in the directions as shown. When the light wave travels, the electric field and the magnetic field, we say E and B, are vibrating in a direction such that E, B, and the direction of wave travel are mutually perpendicular to each other. All electromagnetic waves have the following common points. First, they can travel in vacuum, or we say electromagnetic wave does not require a medium for its propagation. Second, all EM waves can travel at the speed of light in vacuum. The speed of light in vacuum is c equal to 3 times 10 to the power 8 meter per second. Also, all electromagnetic waves are transverse waves. The last, all EM wave possesses all the wave phenomena, that is, reflection, diffraction, and interference. Electromagnetic spectrum. The wave from 1 to 7 are called EM wave because they all travel with the speed of light in vacuum, c. These waves are radio wave, microwave, infrared, visible light, which varies from red light to violet light, ultraviolet, X-rays, and gamma waves. The waves are arranged in this order such that radio waves has the longest wavelength, whilst gamma wave has the shortest wavelength. Since speed equal to f lambda and all the speeds are equal, therefore radio wave has the smallest frequency, while gamma wave has the greatest frequency. Let's consider the propagation of radio wave. In the figure, a radio wave passes over a hill and reaches the house. How does the house receive the radio signals sent by the radio station far apart? When the radio wave passes through the hill, it bends around the hill, and by diffraction, it reaches the house. Therefore, due to diffraction of the wave, the house can receive the radio signal. If the wavelength of the radio wave increases, that is, if lambda 2 is larger than lambda 1, the diffraction of the wave would be more significant. Therefore, the radio wave will be received better. That is, if radio signals of frequency 500 MHz, we have the lambda 1 equal to c over f1, which is 3 times 10 to the power 8 over 500 times 10 to the power 6, which is equal to 0.6 meter. For another radio signals of frequency 200 kHz, the wavelength of the radio wave lambda 2 will be 3 times 10 to the power 8 over 200 times 10 to the power 3, which is equal to 1,500 meters, which is much longer than lambda 1. Therefore, the radio wave of frequency 200 kHz would have greater diffraction. Therefore, this signal would be received by the antennas in the house in a better way. Let's see for microwave the applications of it. Microwave can be used in radar to detect distance by the theory of reflection. Consider the microwave pulse sent by the transmitter towards a flying object and is reflected by the flying object back to the receiver in the transmitter. The transmitted signal and the reflected signals has a time lag of t. By the equation speed of the wave equal to distance over time, we got c equal to 2d over t, where d is the distance of the flying objects from the transmitter. We can find d equal to ct over 2. Second, microwave can be used in cooking in a microwave oven due to wave carry energy. When the microwave passes through the food, the electric fields of the microwave will make the water molecule inside the food vibrate violently. Hence, heat is produced. Microwave can be also used as a satellite communication. Since microwave is EM wave, which can travel in vacuum with the speed of light, the microwave will be sent from the transmitter at position A on the Earth towards the satellite in the outer space, and the satellite receives the microwave pulse and send it back to the receiver at position B on the Earth. In this case, signals can be transmitted from A to B through the satellite. Infrared. Infrared is emitted by hot objects. The higher the temperature of the object, the greater intensity of infrared is produced. Let's see some uses of infrared. Infrared can be used in remote control due to it carry energy. Second, infrared can be used in light vision glass 夜視鏡 because it carry energy. Next, there are infrared photos. Reflection of visible light. When white light passes through a glass prism as shown, a spectrum is formed. At the air to glass boundary, the light reflects. For example, the light reflects at point P. Reflection is due to the change of speed of the wave. When the light travels from air to glass, it bends towards the normal. With angle of incidence I and angle of reflection R, it is known that refractive index of glass is equal to psi I over psi R. From the diagram, we see that the reflected angle for red light is larger than the reflected angle for violet light. Therefore, refractive index of glass for red light would be smaller than the refractive index of glass for violet light. Also, refractive index of glass equal to the speed of the light traveled in vacuum over the speed of the light traveled in glass. Because I is larger than R, therefore the speed of the light in glass will be smaller than that in vacuum. Ultraviolet. Ultraviolet can make some materials fluoresce. Therefore, it can be used to check band looks. Also, ultraviolets can kill bacteria. Therefore, it can be used to kill the bacteria in drinking water before we drink. Also, ultraviolet can produce vitamin D in the human skin. Notice that for EM wave with higher frequency, the penetrating power will be higher. Since X-rays and gamma waves have the highest frequency among all the EM waves, therefore X-rays and gamma waves has high penetrating power. Therefore, X-ray can be used in medical diagnosis. For example, for X-ray checks. Also, X-ray can be used in security check and crystallography. For gamma wave, it has the highest penetrating power among all the EM waves. Therefore, it is widely used in radiotherapy, 放射治療. And also, it can be used in cleansing medical equipment. That is, by passing through gamma wave into the medical equipment, it can kill all the bacteria inside.